Hey everyone, welcome back to my channel Physics with Sabi. Let's have a look at the amazing question taken from laws of motion. A block of mass m placed on the inclined surface of a movable wedge of mass capital M with an angle of inclination theta is as shown in the figure. Find the acceleration of the block as well as the wedge with respect to the ground when the block is released. Assume all the surfaces are frictionless. Before going to check out my solution in detailed way, explore your great thoughts to crack at it. Now you watch the solution. Here the situation is like this. Block and wedge both are moving with some accelerations. Here we have to figure out the acceleration of both the bodies. Now we see the kinematics of both the bodies. Here this is a wedge on which a block is placed. After some time the wedge is moving towards left with some acceleration A. At the same instant the block is moving from here to here with acceleration small a. Generally the people will assume that the block is moving along the inclined surface. But in reality it moves like this. It is not moving along the inclined. If the wedge is stationary, certainly it will move along the inclined surface. Now here we have to find out the accelerations of both the bodies. Means we have to find out the acceleration capital A of this wedge as well as the acceleration small a of this block. This small acceleration is divided into its components. One is ax, other one is ay, and the angle of inclination is theta. If this block moves along the inclined surface only, then this beta certainly is equal to theta, but it is moving along this line, therefore this beta is not equal to theta. Here is also theta. Now you see the cause of motion. When the block is released at this position, it slides on the inclined plane and this wedge is also moving towards left. Why it moves like this means the weight of the block is acting in downward direction, that is mg. Due to this, action reaction pair acts between the block as well as this wedge. This wedge exerts its normal reaction on the block in this direction, normal to its inclined plane, as well as this block also exerts the normal reaction on this wedge normal to the inclined surface. Means these two normals are action reaction pair. And here also one normal reaction acting on this wedge in the upward direction, but there is no use of that, so it is ignored. Now normal reaction acting on this wedge is divided into two components. One is vertical component, that is n cos theta, and horizontal component, that is n sin theta. This normal reaction acting on the wedge is opposite to this, therefore these two components also opposite to these two components. Therefore it is n sin theta, here is also n sin theta. It is n cos theta, it is also n cos theta. Now we can write the force equations for this block as well as for this wedge. This is the reference system that we have taken. We have to apply the forces along the horizontal and vertical direction. First I am writing for the block. In the horizontal direction, how much force is acting? N sin theta. Therefore n sin theta is equal to mass of this block small m times of the acceleration produced in this block in the horizontal direction, that is ax. Therefore n sin theta is equal to max. On this block in the vertical direction, the forces acting are mg and n cos theta. As a result, this block is going down, therefore mg minus n cos theta, mg minus n cos theta is equal to mass times of the block into acceleration of the block in the downward direction, that is ay. This is equation number 2. For this block we have two equations. For this wedge also we can write one equation, that is on this wedge one horizontal force is acting, that is n sin theta. Due to this acceleration will be caused. Therefore I can write n sin theta acting on this wedge in the horizontal direction is equal to mass times of this wedge into acceleration produced in this wedge. Therefore, three equations, but how many unknowns are there? N, Ax, Ay and capital A. Four unknowns are there. Therefore, we require another one equation. For that, you see this Ax and this Ay, we have to write the components along normal to the inclined surface. Y means to maintain the contact between the two surfaces, the acceleration of the block normal to the inclined should be equal to the acceleration of this wedge normal to the inclined. The acceleration of the block normal to the inclined can be written as Ay cos theta minus Ax sin theta, which is equal to acceleration of this wedge normal to the inclined, that is A sin theta. Therefore, you write A sin theta. Solving 1, 2, 3, 4 equations, we will get the 4 unknowns. This is one method. Now, in method 2, we consider that the acceleration of the block along the inclined surface is A with respect to the wedge. But the acceleration of the wedge is A. In which direction? Towards left. Therefore, the block has two accelerations. One is small a, other one is capital A. Small a is the acceleration of this block with respect to the wedge. Capital A is the acceleration of the block since it is placed on the wedge. Then the resultant acceleration of this block along this direction, AB. Therefore, AB can be written as acceleration of the block with respect to the wedge plus acceleration of the wedge. Now you write the force equation acting on this block in the horizontal direction and vertical direction. In the horizontal direction, the force acting on this block is nothing but n sin theta. N sin theta is equal to mass times of this block into A cos theta minus A. A cos theta minus A. This is equation number 1. And for this wedge, we can write n sin theta is equal to mass times of A. N sin theta is equal to mass times of A. This is for this wedge. For this block, in the vertical direction, we can write mg minus n cos theta. Mg minus n cos theta is equal to mass times acceleration of the block in the downward direction, that is A sin theta. M into A sin theta. Now, how many equations we are getting here? 1, 2, 3. One is for this wedge and 2 are for this block in the horizontal as well as vertical direction. So 3 equations. How many unknowns are here? N, A, capital A. 3 unknowns, 3 equations. We can solve this easily compared to the previous one. Now, what is this Ax? Ax is the acceleration of the block in the horizontal direction. A cos theta minus A. Here, wedge acceleration is also considered. Therefore, we get this Ax with respect to the ground only. And Ay means the vertical acceleration of this block in the vertical direction is equal to A sin theta. Here you see A sin theta. Therefore, AB means the acceleration of the block with respect to the ground is equal to root of Ax square plus Ay square. In method 3, we consider along the inclined as the x-axis perpendicular to the inclined y-axis. We apply the force equation for this block with respect to the wedge frame which is moving with acceleration capital A. In accelerated frame, to apply the force equation, we have to consider pseudo forces also. This wedge is moving towards left with acceleration A. Therefore, pseudo force acting on this block is equal to mass times the acceleration of the wedge, which is opposite to acceleration of the wedge. Along the perpendicular to the inclined, it is in balanced state. Therefore, upward force n plus ma sin theta is equal to mg cos theta. And along the inclined surface, we can write mg sin theta plus ma cos theta. Mg sin theta plus ma cos theta is equal to mass times acceleration produced in this block along the incline, that is A, m into A. On this wedge, n sin theta is acting towards left, therefore it produces the acceleration A in the wedge, therefore we can write n sin theta is equal to ma. Here we got three equations, three unknowns, n, a. But this A is acceleration of this block with respect to the wedge only. Our target is to figure out the acceleration of this block with respect to the ground. The angle between capital A and small a is pi minus theta here to here. Because this angle is theta, therefore the remaining angle is pi minus theta. Therefore, acceleration of block with respect to the ground, therefore we can write under root of a square plus 2aa cos the angle between them pi minus theta. In all the three methods, it is clear that the third method is very comfortable. Okay, you can follow this. Are you enjoyed this video? Subscribe for future updates. Please like and share the video. Have a nice day.